Okay, so let's look at number 2. This is the droplet, and it says it creates circular drop, lands a large bowl, it creates circular ripples. The ripples expand to a radius of 2 meters before dissipating. It's a really large bowl, okay? 2 meters in, does it say diameter? Radius. It's really large bowl, okay? It's like a pool, okay? It's like some kind of pool. All right. So constants. What is constant in this situation? Size of the dish. Okay, but size. So that is kind of nondescript. We need to be really specific about what we mean. So when you say size, radius of the dish, okay? So A, constants. Radius of the dish. What else? Radius of the ripple is constant. Agree? Well, the ripples don't ever stay stationary. So even the outermost ripple is growing, and so the ripples are always changing. So I don't think there's any ripple that has a constant radius. Agree? What else is constant in this situation? What's that? Okay, so area, that is a quantity, but it's totally nondescript. Area of what? There's maybe 3 or 4 things we could talk about the area of. So when you said area, what were you thinking? What's that? Area of the circle. The ripple? Area inside the ripple, is it constant? No, it's growing because the ripple is growing. So is there a constant area we could talk about? Yeah. Okay, yeah, so the area, so it's the surface area of the dish, or the surface of the water maybe. So area of the surface of the water. Area of the water surface. The capacity of the bowl. Capacity of the bowl. These are constants. Okay? Now there's another constant that's implied, but they don't say it here, and that would be the speed of the ripple. Speed of the ripple's radius. Okay, so for any of these, we could define parameters. This says define parameters for any ones that you do not know. Are there any of these that we do know? So the maximum radius of a ripple is 2 meters. So if that's what you intended to say before, sorry that I said that. So yeah, so the maximum ripple radius 2 meters, that would be constant. All these other things that we've said would be parameters. So we call the radius of the dish, say, capital R. We could say the area of the surface of the water is, say, A. We could say sub S. Capacity of the bowl, we could call V for volume. Speed of the ripple's radius, we could call that little s, say, for speed. Okay? And these are all parameters because these quantities don't change in the given situation. They're not varying. They're constant. Okay, variables. So the radius of a ripple is an obvious one. And we want to use units here. Radius of ripple in what? In meters. Call that little r. Okay, what else? Area inside the ripple. In meters squared. Capital A. All right, what else? What are the variables? What's that? The volume of the drop of water? Won't that stay constant as it falls? And then it'll stay constant as it falls, right? The volume won't change of a drop. Yeah, I think the volume of a drop is going to stay constant. Yes, sir? The volume of water in the bowl. Yeah, it's good. Volume of water in the bowl. Is that what you kind of intended? Okay. So volume of the water in bowl in meters cubed, say, and we can call that like little v. Okay. So we've got these two for part C. The outermost ripple's radius and the enclosed area, we define those as little r and a. And they say in a relationship between those two, And so equations and expressions are what we use then of variables to create other quantities and other variables. And so what's the relationship between the area enclosed by a ripple and the ripple's radius? Circular, right? So A equals. So there's that relationship between what we call the radius of the ripple r and A, and these are changed. So as r changes, we can think of r as the independent variable. As r changes, then A depends or is determined by the current value of r. And those, you think of those changing together, right? The radius is increasing and the area is increasing. They increase together. Okay, so pi is, these are variables. This pi is constant, right? Pi is constant. And these are variables. Okay, now the number of seconds is another variable that we didn't write. Number of seconds since the drop hit the water. And we can call that little t. It's another variable. And so they want between the outermost ripple's enclosed area and the number of seconds since the droplet hit the water symbolically. So notice that we said that s was the speed of the ripple's radius. And we should have said like in meters per second. We should have had, and we said that's a constant. So if we want a related to t, well, it'd be nice if we just had r related to t, then we could easily get a related to t, right? So how is r related to t? If s is the speed of that ripple, and t is the number of seconds since the drop hit, then what's the relationship of r and t? The radius would be s times t, right? It would be how many meters it's expanding every second, and then for that many seconds, times that many seconds would give you the current value of the radius. Okay, so you'd have variables here, r and t, constant parameter s. And if r equals st, then we can write what they're saying. We can write what the enclosed area is now in terms of t instead of in terms of r. So then what is a? A is pi times, what's that? S. So if r is st, then r is st, and it's still the same relationship. A still equals pi r squared. It's just now that we know that r is st. So it's still pi r squared, but it's pi st squared. And now this relates the variable t and the variable a. Constants s and pi.
Do we need to use a since we know the area?
No, it's changing. It's a variable, right? It's the changing area inside the ripple. So no, so express the relation between the outermost ripple's enclosed area and the number of seconds. So it's just saying the first one. It's just they're just picking one ripple. It's still a growing ripple. It's still a ripple that's growing. They're just specifying that's the first one. Okay. But its area is still changing as t changes. Okay, questions on number 2. I went a little fast, but because we got a little behind. But any questions on that one? Yes.
What is 2 meters?
Just to give you something constant that you might list up in part A, just to give you some constant value as part of it. But that 2 meters is basically that constant value where the ripple runs out. When the ripples grow to 2 meters, then the ripples just dissipate. So it's like the maximum radius of a ripple.
What if I calculate the area using that?
But the point of this is that the area inside the ripple is a changing quantity. That area for a moment at the end is what you calculated. But then before that, it's changing. It starts at 0, and as the ripple moves out, it's a changing quantity. That's the big point of this problem. The area, time, and radius are all changing together. And then that final area is what you calculated. It's just the last area, the greatest area. Other questions? Okay, so we want to do a little bit of GC activity. So if you got your laptop, pull out your laptop and open up GC, graphing calculator. And we're going to start talking about dealing with points and graphs and sets of points and all these things that you read about, okay? So in GC, just open up a new window. Should look like this. Okay, so so every command line that displays something, what is it going to do? It's going to display a point or a set of points. And what set of points does it display? It displays the set of points according to the mathematics that you wrote in that display line. This is not a programming language. The great thing about Graphing Calculator is it tests your knowledge of the mathematics. You have to put in correct mathematical statements consistent with the rest of the mathematical world and textbooks and our textbook. When you put in the correct mathematical statement that represents a set of points, then GC says, okay, I will graph you that set of points. So let's start with 1 point. How do you graph 1 point on GC? So you're going to do Control 2, and you should get something that looks like that. Did you get that? Okay, so now you're going to put in the x coordinate on top, and so it lists the ordered pairs vertically. And you do Control 2. So we'll put in, say, 6 for x, and then select y and replace it with 3. And if you graph it, lo and behold, it did exactly what we told it to do. We said, we want you to graph the single point 6, 3. And there it was. There it is. Shows up. Okay, so now I'm going to graph another one here. How about 3, 1.5. Oh, so then to start a new command line, you're going to do command return or control return. So command return on Mac, control return or control enter on PC allows you to do a new command line. Everyone, good. Can you guys troubleshoot? You guys able to walk around and troubleshoot? If you want to go in and edit one, so you can go back to the first one, edit it, you can just go in there like a word processor and change them. So I changed the first one to 4, 2. Okay, now I want to display every point on the line that goes through those 2 points. So what we need is a mathematical relationship that's true about every point on the line that goes through those 2 points. So don't think about in the past like, oh, I'm going to find the slope and the y-intercept and plug it into the... We're not going to do that. We're going to think about what's the relationship between y and x that characterizes these 2 points that I did. What is the relationship? 4, 2, 3, 1.5. What's the relationship between y and x that characterizes both of those points? No. So how does y relate to x? So we think of y and x are changing together, but how are y and x related? We got 4, 2, 3, 1.5, and I had 6, 3 before also. What's half? Y is half of x. Is that right? Y is half of x. So we're going to type that in. Y equals half of x. So what's it going to do? It's going to graph every point, the set of ordered pairs, that makes that mathematical relationship true. And so that'll be all points like the first 2 that we graphed, where y is half of x. Choose a better color. Okay, so now suppose I only want to graph some of those points. I just want to graph the points between, say, starting from x equals 2 to x equals 7. So I'm going to revise this set of points. So this is saying all points whose y coordinate is half the x coordinate. But then I'm going to put a comma, and I'm going to say I only want that for the x values between 2 and 7. So how have you done that all your math career? How do you communicate? I want all x values between 2 and 7. Yeah, okay, so it doesn't know the parentheses. So for parentheses, it's going to use them like parentheses, like multiplication and things like that. So what's the alternative? Greater than or less than. So we want all x values greater than 2 and less than 7. So we can start with the 2, less than x, less than 7. This is not a programming language. This is consistent with everything you've ever learned in math. So we want all points where y is half of x and x is between 2 and 7. So now it just only graphs all those points such that x is between 2 and 7, and you get this part of that line. Does that make sense? Okay. Remember, you give it the mathematics of a set of points, and it graphs those set of points. That's the way you got to think about GC. You give it the mathematics for a set of points, it plots those points. If there's an infinite number of them, it's not going to show a bunch of dots, right? It takes too long, so it just makes a continuous sweeping stick or curve. But what you're looking at is, what are you looking at? You're looking at a whole bunch of points. When you look at that blue line, what you're thinking is, oh, that's a bunch of points, a lot of points, and every point has a y coordinate half of the x coordinate. All right, now we can just type in n. And as soon as you type in n, notice down here at the bottom, the slider comes up. And so right now, it's showing you that n equals 1. And that's because the slider is set at 1. So if you come down here and grab onto it and move, you can change the value of n according to your liking. And then if you look up in that command line, it's going to show you the current value of n up there. Right now I've got n at 6.6. And it's telling me n is 6.6. What is this like that we just worked on, we just talked about? I can come down here and choose the value of n. What is this like? Thank you. Independent variable. So this is like an independent variable. N is a variable, and I get to choose what value it is. Okay, so now what I want you to do is, on the next, make a new command line, and I want you to create a point that will move. You'll be able to move it along this line. Can you create a point to be able to move along this line according to changing n? If you change n, your point would move along this line. Can you do it? Can you do it? Put some things together here. So rather than, so that we did a fixed point for 2, but now I want a point such that if I change n, the point will move along this line according to what I choose n to be. Anybody got it? No one yet? Yeah, you can work together. But first of all, it's going to be a point. So how do you graph a point on GC? Okay? And then you want it to be movable according to the value of n. So what are you going to pick for that point's coordinates? Anybody got it? A few, a couple. So it's first and foremost, what is it that we're graphing? A point. How do you graph a point? We did it at the beginning. Control 2. So now, I want to be able to control, with n as an independent variable, control that point, but I want it to be according to our relationship, right? So what should x be? I want to be able to control it. N. Let x be n. But now I want that point to be according to our relationship, or just be able to move on that line. Can you finish it? Go. Can you finish it? Is it ny? Does that work? No, that doesn't make sense. Two n. Is this what? Will that be a point on this? Y always twice x. Okay, here's n and 2n. How'd we do? Other way. Do you want me to type in other way? Other way. And over 2. So the relationship is, this relationship of the graph, the line that we graphed is what? Y is half of whatever x is. What is x for our point, our moving point? N. So we want y to be 1/2 of whatever x is. X is n. So 1/2 of n. Right? So now this idea of independent and dependent variable. So independent, I can come along and choose the current value. It's a changing quantity. It's the x value on the graph. Y is dependent. It's always 1/2 of whatever the current value of x is. So as I change n, I'm changing the x, or the independent variable, changing the value of x. And y will always stay, according to that point that we graphed there, it will always be 1/2 of whatever the current value of n is. Does it make sense? Okay, now I want you to go to Blackboard and open up a file in the homework section. Little practice here. So if you go to Blackboard and go to Readings and Homework, there's a new post. It says, GC file for class, Tuesday 119, coordinate point activity students. You download that and open it up. Everyone found that? On Blackboard, in Readings and Homework, the first post has a link with a GC file that you're going to open. And it should look like this. So it has a bunch of headings and then a bunch of blank command lines that you're going to fill in. That's going to be your task. I'm going to show you some things on a graph, and you're going to fill those in so that yours looks like mine. Did everyone get the file open? Everyone's good? Here we go. So the first thing is, I want your fixed points are these 3 points. Okay? Don't start yet. Let me go through the whole thing. The first thing is you're going to just plot 3 fixed points like I've shown you. The next thing you're going to do is you're going to plot this set of points. You're going to plot this set of points that includes the 3 points that you've already plotted. And then the next thing you're going to do is you're going to plot the movable point that still holds that same relationship. And then the last thing we'll do after you're done with that. So those are the first three tasks. First three tasks are the fixed points shown, the set of all these points, the three fixed points are included in those, and then the movable point that you can move within. Yeah, don't forget that. Yeah. Just ignore the view line. Don't add that in. You're going to start with the one under fixed points. Thank you. Yeah, just ignore the view line. Don't do the view line. Okay? So you keep yours looking like this. You're just going to fill in the question marks. Fill in the question marks to get this image. Go.
If you don't have a laptop, you should be writing exactly what you look to do later at home on paper. And you should be copying notes.
Is it a line? No, it's not a line. Oh, you may have already discovered. Instead of just clicking on the button and moving the button, you can also play. So you can just push play and let it change on its own. Okay? So here's just n changing. So I'll just push play and let it go. What's the last heading say? What's it? Bars? Bars. Something about bars, right? Bars. Any questions about this so far? The points, the fixed points, the curve of points, and the movable point. When you're looking at that curve, what are you looking at again? Is it a wire? What are you looking at when you're looking at that curve? What's that? Plotted points. How many plotted points are you looking at when you look at that curve? All of them, which is how many? 4? 4 points when you're looking at that curve? How many? 3? No, an infinite number of points. The curve, the purple curve, the pink curve, is an infinite number of points. It's easier to draw it like a curve. If we really drew it like it would look like a whole bunch of dots all smushed together. But that takes too long, and then we wouldn't get them all anyway, right? So because there's an infinite number. So we use a representation of a smooth, sweeping curve, but you have to think in your brain, oh, that's just a bunch of correspondence points between an x and a y that's dependent on it. And what's the relationship for this one? Every time you have an x, the corresponding y is the square root of x, right? The square root of x. So it's all the points that show that relationship. Of y is always the square root of whatever x is. That's what you're looking at when you look at the curve. It's really important that you think of graphs that way. A set of points. Okay, the last thing is, if you go up to graph, and I'm going to pause it here. Go up to graph and pause please. Thank you. Graph, draw axes. So we're going to turn off the axes. And when you turn off the axes, I have something that you don't have. And what I have is bars along the x and y axis that are showing the current values of x and y. So that the length of that blue bar is showing the current value of x. And the length of that red bar is showing the current value of y. And so if I change, for the movable point. So if I change n, look what happens. So right now n is 6.2, and what's the value of y right now?
3.
No, what's the value? Exactly, what's the value of y right now? Exactly? Haven't heard it yet? No, exactly. The square root of 6.2 is the current value of y. And so my blue bar is showing that my x value is 6.2, and that my y, and the red bar is showing my y value of the square root of 6.2. So you have two more command lines to create those sets of points. So that blue line then is its own set of points, showing the x value of the movable point. And that red bar is its own set of points, showing the y value of the movable point. So you have two more command lines to see if you can recreate the blue and the red lines. The bars that are showing the current values of x and y. Go. Okay, so what's the equation that's every point on that blue line? So what equation tells us every point on that blue line? Yeah. Y equals 0, right? Y equals 0. All those points are characterized by y equals 0. But then we need to start it at where? On the left side, we're starting it at 0, and it ends at, where's the right side of the bar? What? A variable. What's the variable? N. So we need y equals 0 from x equals 0 to n. And then as n changes, it's going to do what it's doing. Y equals 0, x starting at 0 and ending at n. Just like the curve. But on the curve, it's all the points such that y equals square root of x, from 0.5 to 10. Now you want all the points that have a y coordinate of 0, from 0 to n. Okay. You can stick around a little bit and keep working on the red one if you want. We can help.